Okay, my dears, so we're going to go into our content library. We're going to go to probability, and we're going to select the compound probability section. Okay, letter page. We're going to learn this new term. Compound probability is the probability of something happening after another thing happens. Okay, and we're going to be learning about these words, or versus the word and. Okay, so or would signify that I'm going to pick something, or I'm okay with picking another thing. It's like I'm okay with two things happening in my probability. And means that one thing has to happen and the other thing also has to happen. Okay? So let's look at some examples. What is the probability that I roll a 3 on a die or I roll a 5 on a die? Well, let's think about a die. A standard die has faces of 1, 2, 3, 4, 5, 6. That's one of these number cubes you'll see on the state test is what they call them. That they have their little dots on them or what have you. Okay? So, to roll a 3 on a die, well, my probability for that is there's 1 3 out of my 6 options. I could also roll a 5 on a die, so that's also 1 option out of 6 options. If I want to roll a 3 and I'm also okay with rolling a 5, well, that just means that I'm okay with getting 2 out of 6 things. Okay, and I'll simplify that down to 1/3. Looking at what is the probability that I roll a 3 on a die and I roll a 5 on a die. Okay, so that's different because I'm not just doing it once. I have to roll a 3 first and then roll a 5. So again, I could roll a 1, a 2, a 3, a 4, a 5, or a 6 on my first roll. Oops. And then I could also roll a 1, a 2, a 3, a 4, a 5, or a 6 on my second roll. Now it doesn't tell me I'm rolling a second time, but I have to assume I'm rolling a second time because I can't roll a 3 and a 5 at the same time. They have to be 2 separate rolls. So now that's going to change my sample space. I have to write out all the combinations. So I could roll a 1 on my first try, and then a 1 on my second try, a 1 on my first try, and then a 2 on my second try, a 1 on my third try, on my first try. Oops, sorry guys, hold on. Let me erase this little bit. Like I said, a 1 on my first roll, a 1 on my second roll, a 1 on my first roll again, and then a 2 on my second roll. I could roll a 1 on my first roll and a 3 on my second roll, a 1 on my first roll, and a 4 on my second roll, a 1 on my first roll, a 5 on my second roll, a 1 on my first roll, and then a 6 on my second roll. So those are my options if I roll a 1 on the die first. I could also roll a 2 on the die. If I roll a 2 on the die during my first roll, I can roll a 1 on my second roll. I could roll a 2 on my second roll, a 3 on my second roll, a 4 on my second roll, a 5 on my second roll, or a 6 on my second roll. But a 1 and a 2 aren't the only things I could roll on my first roll. I could also roll a 3, a 4, a 5, or a 6. Those could all be my first rolls. So I'm just going to fill in what I could get, because with each of those, I could get a 1 as my second roll. Oops. I did a little mistake, hold on. I could get a 2 on my second roll after each of these first rolls. I could get a 3 on my second roll after all of these first rolls. I could get a 4 on my second roll after all of these first rolls. I could get a 5 on my second roll. Oh, I keep wanting to write 3. I could also get a 6 on my second roll. There we go. That's a 6. And 6, 6. Good. So that represents all of my rolls that I could get. Okay. I can roll a 1 and then a 1 and then a 2 and then a 2 and a 3, a 2 and a 4, a 3 and a 1, a 4 and a 3, a 4 and a 4, a 5 and a 6, a 5 and a 2. These are all different types of rolls, okay, with us. This is my first roll. So my first roll outcome, and then my second roll. Okay, so now I want to ask, which one of these combinations do I get a 3 on a die and then I get a 5 on a die? So a 3 on my first roll is going to be any of these in this third row. And a 5 on a die, well, that's only one of these. Do I get a 3 on a die and then a 5 on a die? However, now my sample space is much larger. There's 1, 2, 3, 4, 5, 6 across and 6 down. That's going to lead to a sample space of 36 total things now. A total 36 total outcomes possible. So that's my 36 on the denominator. And how many have a 3 and then a 5? Only 1. Okay? So, I know you're wondering, what is a faster way for us to do this? So I'll tell you. To get from 1/6 on the 3 and 1/6 on the 5 to 2/6, why, that means that in order, if I have if I have the word or, I'm going to add my two fractions. So I'm going to add, oops, I opened up Microsoft Word by accident, guys, sorry. Okay, I'm going to add probabilities. For the word and, well, I had the probability of rolling a 3 was 1/6, and the probability of rolling a 5 was 1/6 on a regular die without combining them. And to get to 1/36, that meant that I had to multiply the probabilities. So, let's see how it works with our little trick. So now we don't have to write out all of the possibilities. For example, what is the probability that I spin a number less than 4 on the spinner, or spin a number greater than 7 on the spinner? Well, let's draw the spinner now. Whee! So please draw your spinner. The spinner is going to have 8 sections. 8 equal sections, or as equal as you can make them. And let's do 1, 2, 3, 4, 5, 6, 7, and 8. And if you want to take a second and just redraw that spinner, because we're going to use it in the next question as well. So I'm actually going to lasso it here. And copy. And paste, because I can. Okay. And I'm going to pick blue. So, to spin a number less than 4 on the spinner, or spin a number less than 7 on the spinner. So the probability that I spin a number less than 4. Well, there are 8 possible outcomes. And so a number less than 4, well, let's highlight those. That would be a 3, a 2, and a 1. So that's going to be 3 out of 8. The probability of spinning a number greater than 7 well, let's see. That would be just 8. So that probability is actually 1 out of 8. So the probability of spinning a number less than 4 or greater than 7 would be 3/8. Now, or again meant addition, plus 1/8, that's the probability of greater than 7, and I get 4/8. And now I just have to simplify that to 1/2. So that's my probability of spinning a number less than 4 on the spinner, or to spin a number greater than 7 rather, on the spinner. Okay, let's try it with the word and. What is the probability that I spin a number, again, less than 4 on the spinner and spin a number greater than 7 on the spinner? Well, I remember that the probability of spinning less than 4 on the spinner was 3/8, and the probability of a number greater than 7 was 1/8. So I'm just going to copy that over here. Oops. Let's undo that. I copied it as a number, as words. Let's do this here. Okay. So a probability number less than 4 was 3/8, and a probability of a number greater than 7 was 1/8. Okay. Sorry guys, 1 second. Okay. I'm just going to rewrite that then. Sorry guys, technical difficulties. So the probability of a number less than 4, we said was 3/8, and the probability of a number greater than 7 is 1/8. For and, that means multiplication, if we remember. So and means I'm going to multiply. Okay, don't forget that. This is multiply. Okay, so let's multiply then. The probability of a number then less than 4 and greater than 7 would be those 3/8 multiplied by 1/8. And if you remember your multiplication of fractions, you just multiply across. That's why I had you practice those on Mathletics. So 3 times 1 is 3. 8 times 8 is 64. Then you have to ask yourself, can I simplify 3 over 64? Well, 3 goes into 6 twice, but 3 doesn't go into 4 nicely. So I'm just going to leave it like that. Okay, so that's what it looks like in action. Or, and then and. Okay? Remember that or, I'm going to highlight this one. I forgot to highlight this one. Or means to add, and means to multiply. Okay, you do still have to find these probabilities of each part first, though, of the beginning, before the or, and the after the or, and before the and after the and. So let's look at these cute little emoji cards. In a board game, students draw a card, replace it, and draw a second card. Determine the probability of each event. So here are my 8 cards. We have an angry card, a sleepy card, a heart card, and a crying card, it looks like, or a laughing card, I guess, and an angel card. So I'm just going to write all these out because I know it's probably going to be helpful. So I'm going to have 1, 2 angry cards. I have 1, 2 sleeping cards. These are my sleeping. I have 1, 2 heart eyes, I guess. Heart eye cards. Is this guy laughing, crying? I'm gonna call him a laugh cry card. I only have 1 of those. And then I have an angel card. So in total I have 8 cards. So what's the probability a student draws a heart eye card or an angel card? So or again means addition. So I still have to find the probability of the heart-eyed cards. I'm going to draw a little heart, a heart-eyed cards. Well, I have 2 heart-eyed cards over the 8, which is 1/4. And I have the probability of an angel card is 1/8. So I'm actually going to keep these in 8s because I want to add fractions with like denominators, right? So probability of a heart or an angel would be 2/8 plus 1/8, which is 3/8. And that's it. Let's keep going. The probability a student draws a sleeping card and an angry card. So the probability of sleeping is, well, we have 2 out of 8 again. The probability of an angry card is 2 out of 8 as well. Probability of sleeping and angry would be 4/8. And I simplify that to 1/2. Okay? Now, oh, I spelled probability wrong here. Let me get reattach my keyboard. Okay, so we have the probability, hold on. Okay, let's see if that worked. Yes. Okay. Probability of a student drawing an angry card and a laughing card and an angel card. Oof, lots of cards. So the probability of drawing, that's a P, an angry card. The probability of I guess it's a laughing card. And the probability of an angel. So probability of angry was 2/8. Probability of a laughing card was, let's see how many laughing cards we have. Laugh cry is 1. We have 1 out of 8. And the angel card, this is why we write it out, because I can't tell all these pictures at once. 1 out of 8. Okay. Now we're using the words and here. Okay. Okay, well, actually, let's go back to number 2 later. And here. So we're going to have the probability of an angry and a laugh and an angel would be 2/8 multiplied by 1/8 multiplied by 1/8. So obviously we're going to use our calculators here. I don't think you should be able to multiply all of this. I think you should know how to do 2 times 1 times 1, however. Oh, I think you know that 2 times 1 times 1 would be 2. Okay, and then we're going to do 8 times 8 times 8, and we're going to get 512. This can be further reduced. Divide both the numerator and the denominator by 2. I get 1 over is 256. Okay, I'd like to go back to number 2 because I made a mistake here. I thought we were still doing another OR problem, but we're actually doing an AND problem. So we don't add 2/8 plus 2/8. Let's go back here. So to refresh our memories, we have the probability of sleeping was 2/8. The probability of angry card was 2/8. I want sleeping and angry. So we have that 2/8 times 2/8 multiply across. 2 times 2 is 4. 8 times 8 is 64. And now we're going to simplify this. Well, let's see what numbers go into 4 and 64. You could use 2. If you use 2, you'll get 2 over 32. But you have to recognize that that can still be simplified more. You can simplify again by 1 rather. 2, and you get 1, and this you get 16. Or you can go from 4 over 64 to 1 over 16 by dividing by 4. Okay? So, I just wanted to fix that part. Oops, accidentally wrote too many numbers there. Okay? I want to fix that one. Gotta be careful. See, even I gotta be careful with the ands and the ors. Alright, next. What's the probability a student draws a sleeping card or a heart-eye card? Oh boy, okay, well, probability of sleeping. What was that? It was 2 out of 8. And the probability of that heart-eyed, I think, was also 2 out of 8. Let me just check. Heart-eyed, 2 out of 8, yes. Always look back at what you did. Okay, so probability of a sleeping or the heart, or means, again, addition. So 2/8 plus 2/8. You add them, you keep the same denominator. You have a 4 on top. You reduce this to 1/2. And our last problem. What is the probability a student draws an angry card or a sleeping card and a heart-eyed card? Okay, so let's do this in order. The probability of an angry card, the probability of a sleeping card, the probability of a heart-eyed card. So we know angry, sleep, and a heart. This is 2/8. This is 2/8, and I believe an angry was 2/8 as well. So let's see. First, let's see the probability of an angry or a sleeping card. So the angry was 2/8. It's or, so I'm going to add. And sleeping is 2/8. So I'm going to get 4/8. Now I have to do and a heart-eyed card. So and a heart-eyed card would be 4/8. That's the probability of angry or sleep, right? And then and means we're going to multiply it by the probability of a heart-eyed card, which is 2/8. So I'm going to multiply across. 4 times 2 is 8. 8 times 8 is 64. We can reduce this down to 1/8. Okay, take a second, copy it down. Okay, so what I want you to do now, we just finished this section. I want you to scroll down. I do want you to pause here for about 10 minutes, 10, 15 minutes, and complete these problems, okay? And when you come back, I will have the answers up for you. So just pause here and do your work. So let's go through these problems. For this one, Kylie has a coin and a number cube. She flips the coin once and rolls the number cube once. What is the probability that the coin lands tails up and the cube lands on a 4? I'm going to say that the number cube is a normal number cube. So she has a coin and she has that number cube. So she flips it once. The coin can get a heads or tails. The cube can have a 1, 2, 3, 4, 5, or 6. Okay? So if we set our sample space, well, each head can, we're going to flip the coin first and then get the cube. So you can get a head first and then a 1 on a cube. You get a heads and then a 2 on the cube, a heads and then a 3 on the cube, heads and a 4 on the cube, heads and a 5 on the cube, heads and a 6 on the cube. You can also get a tails and a 1 on the cube, a tails and a 2 on the cube, a tails and a 3 on the cube, a tails and a 4 on the cube, a tails and a 5 on the cube, or a tails and a 6 on the cube. So in total, there are 12 outcomes possible. So let's look on. She wants to know what's the probability of landing tails up and a 4. So we know it's right there. It should be 1 out of 12, but let's see. The probability of getting a tails is 1 out of 2. It's only 1 out of the 2 options in a coin. The probability of landing on a 4 is 1 out of the 6 possible choices on a cube. Let's add 1/2 plus 1/6. Well, they're different denominators, so now I have to convert them. So the common denominator between them would definitely be a 6. So let's change a half into 6. So 1/2 is going to be equal to 3/6. Okay, 3/6 plus 1/6 is equal to 4/6. Well, wait a second. That doesn't match what we said. It should be 1/12. What did we do wrong? And if we look over here, we should read that we added, but this question says and. So we have to be really, really careful. So instead of adding, we should have multiplied. So we have that 1/2 times the 1/6. And that'll get us that 1/12. So be very careful and make sure you read and highlight, okay? It's definitely going to show up on the state test. So let's go on to the next problem. There are 6 marbles in a bag. 3 are green and 3 are yellow. If you draw a marble, replace it, and then draw another. So here's that and. What is the probability of choosing 2 yellow marbles? Okay, so in our bag, there are 6 marbles. 3 are green, and 3 are yellow. So the probability of drawing a yellow first would be 3 out of the 6 marbles. And the probability of drawing a yellow the second time, well, since we're replacing it, our denominator is not changing. That there's still going to be 6 marbles in the bag. So it's still going to be 3 out of 6. Since it's an and, we'll do 3, 6 times 3, 6, and we should get 9, 36, which can be simplified. The number that goes into 9 and 36 is 3. We should get 3 twelfths. But wait, we can further simplify. That'll get to 1/4. So our probability of choosing 2 yellow marbles should be 1/4. Next, one card from a deck of cards is selected and is replaced, and another card is chosen. So again, we have that replacement. This is with replacement. Okay. What is the probability that the first card is a red card and the second card is a diamond? So let's review. In a standard deck, there are 52 cards. Half are red, half are black, which means that there are 26 red cards. There are also 1/4 for each suit. So there's a 1/4 are diamonds, meaning there are 13 diamonds. So let's see. The probability of the first card is a red would be 26 out of 52, which is equal to a half. Now remember, they're replacing that card, so our denominator is going to stay the same. The probability then of a diamond card being chosen next would still be out of 52 cards because they replaced it, but it'd be 13 out of 52 because there are only 13 diamonds, and that reduces to 1/4. So the probability of a red and a diamond would be 1/2 times 1/4, which is equal to 1/8. Okay. Oh, oops. There we go. Let's keep going. What's the probability of flipping 3 heads in a row? So even though there's no and, I know that it has to be and because I'm doing multiple times. I can't flip a head or a head or a head on one flip because there's only 2 sides and one of them is a head. Okay, so I can only choose one at a time, so these have to be and. So let's see. Probability of a heads is 1 out of 2 because the other option is tails. So the probability of a head and a head the second time and another head would be 1/2 times 1/2 times 1/2, which would equal 1/2 times 2 is 4 times 2 is 8. 1/8. Let's keep going. Neil goes to the pet shop and selects a treat for his dog. He chooses one, returns it to the bunch, and then chooses another. What is the probability that Neil selects the bone and then the collar? So, the probability of the bone, let's see, there's 1, 2, 3, 4, 5, 6 items, and the bones make up 3 out of those 6, which we know is reduced to a half. The probability of choosing a collar, well, since he replaces the bone, the denominator stays the same. And that collar, there's only one collar out of the bunch. So 1/6. It says and, I don't care if you circle it, highlight it, put stickers around it, know what you're doing. 1/2 times 1/6 would be 1/12. And luckily you have your calculator for the test, so put that straight in. Make sure that you don't mix up your multiplication on the state test. Okay, don't take your chances. Even if you know it, just double check. Okay guys, 4 more questions. Dexter has 4 different coins in his pockets. He randomly selects a coin from his pocket, replaces it, and then selects another coin. What are the probability that his coins are dimes? Well, I don't know what his coins are. I just know that they're different coins. So, let's just make up his coins. I know he has to have some sort of dimes. I assume the other ones are the normal coins then. Quarter, penny, and nickel. Okay. Now, what are the probabilities both coins are dimes? So, again, even though he doesn't say, it does say actually, this one says and he replaces it, so the denominator is going to be the same. What is the probability both coins are dimes? Since we're doing it again, like if he picks a dime, he can't get more than one dime, so he knows it has to be and. So the probability of a dime is 1 out of the 4 different coins. So the probability of getting a dime and another dime would be 1/4 times 1/4, multiply across. 1 times 1 is 1, 4 times 4 is 16, or put that straight in a calculator. Okay, 3 more questions, my dears. The letters of the alphabet are written on cards and placed in brown paper bags. What is the probability of drawing a vowel, replacing it, and then drawing another vowel? So we're doing a lot of and questions today because when I was looking through state tests, they only had and questions. It doesn't mean they won't have or questions. It means that those are what they expect you to kind of be tricked on. So I want to make sure you're not, because the or questions we kind of covered the other day in class anyway. So let's go back to this. The probability of drawing a vowel. So what are the vowels? Vowels are A, E, I, O, and U. Okay? You should have that sort of background knowledge. If you don't, just memorize it. A, E, I, O, U. So you also need to know the letters of the alphabet. How many letters of the alphabet are you? So if you really, really get stuck on the state test, then write them all out. I'm sure you know your alphabet. But there are 26 letters in the total alphabet. Okay? So the probability of drawing a vowel, well, there are 5 different vowels you could choose from out of the 26 letters. You're replacing it and then drawing another vowel. So the probability of getting a vowel and another vowel would be 5. Ooh, that's an ugly 5. Let me erase that 5. 5/26. Multiply that by 5/26, because that's an and. You'll get 25/676. And you cannot simplify that. Okay, so remember, and is multiplication. And to finish this off, 2 number cubes are rolled sequentially. That means right after the other. What is the probability that the first number cube shows a 2 and a 3, and or a 3, and the other number cube shows an even number? So the number cube is 1, 2, 3, 4, 5, and 6. So you have 2 number cubes. They both are the same. What's the probability of getting a 2? Well, it would be 1 out of 6. The first number cube, right? The probability of a 3 would also be 1 out of 6. So the probability of getting a 2 or a 3 on the first cube would be 2. Excuse me. To get a 2 or a 3, well, we take the probability of a 2, which is a 1 out of 6, and add it, because it is or, to the other 1 out of 6. We get 2 out of 6, which is 1/3. The probability of getting an even number on the other cube, so we have the same sample space for the other cube, be 2, 4, and 6. would be 3 out of 6, which is a half. That means that the probability of getting a 2 or a 3 and the probability of an even would be 1/3 multiplied, because now it's and, before it was or, 1/2, and we will get 1/6. Do simplify. It's always easier to multiply smaller numbers. Now, last one. Mackenzie chooses one candle, returns to the bunch, and then chooses another candle. What is the probability that Mackenzie selects a polka dot candle both times? Okay, so the probability of a polka dot is 2 out of these 5 candles. She replaces it, so it's not going to change the denominator. It's still going to be choosing from 5 things. Again, it says and she's returning it, so that's good. The probability of polka dot twice would be a 2/5 on the first time, multiplied by 2/5 on the second time. We will get 4/25. Well, I don't know about you guys, but there's a lot of math for today. So, this is how you do compound probability, ors and ands. You guys did really well. Look how much math we did. Oh my goodness. Okay. Your homework for this lesson is just this. I'll put the answers up, but I will want to see this with your work, obviously. Okay. Great job today. All right. And you can look back on this video whenever you want. It's going to be right here. Bye, guys.